So let's take a look at finding some intercepts, and we have a example here with the equation y equals x squared minus 3x plus 2. So we have a quadratic equation, and let's find the intercept. So we have the possibility of an x-intercept and a y-intercept. So the x-intercept, all right, we're going to intercept the x-axis by definition when y has to equal 0. Right? That would be a location on that curve, if it exists, right, such that we are intercepting the x-axis. So we've got 0 equals right-hand side. So we have a second order, and just getting more and more comfortable with solving second orders. We've got quadratic equation, completing the square, just good old factoring. And you always want to start there because 2 is 2 times 1 and a 3. So that gives us a chance, and x minus 2 times x minus 1. So you want to go back and review your factoring if that didn't come out very quickly for you. And then the solution would be x is equal to 2 and x is equal to 1. So the answer would be x would be 2 comma 0 and 1 comma 0. The y-intercept by definition would be at x equals 0. So we're just going to go back into this equation right here and just plug in x equals 0 and then solve for y. So we get a 0, x 0 squared minus 3 times 0, so that's another 0 plus 2. So it falls out that y equals 2. And we have some technology, so let's go take a look at it. So over here on Desmos, you can just type in our function y equals x. Then I'm going to go shift 6, puts me in the exponent. 2, I'm going to go right arrow to bring me back down to the line, get me out of the exponent, minus 3x, and then plus 2. And if we just put our cursor over here, we actually see it's going to tell us our points. There's 1 comma 0, there's 2 comma 0, the x-intercepts, also tells the y-intercept, it's 0 comma 2. And it looks like it's going to tell us the vertex right there as well. And so just to see how flexible Desmos is, let's see if we can do this. X minus 1. Oops, minus 1. Oop, I'm in the exponent. I'm in the minus 1. And we get the exact same one. So if we take that off or take that off, we see we get the exact same line right on top of it. So, and let's go ahead and look at another example here. We've got, you're asked to graph the following. So we just want to graph this equation, and what is this thing? I mean, I see some x squared, some y squared, xy equals 0 over here. So what is this thing? We just want to kind of think, right? It is, unlike the last example that was y equal to x squared, here we've got x squared and y squared. So we can't, a little bit tougher to separate. We can't make an equation just y equals. And so, but I do see x squared and y squared. So might as well go in the direction that x squared and a y squared ends up often with a circle, right? The equation of a circle. So at this point, you should be familiar with page 98 in your textbook. There's a big box right there. And so we've got some work to do is the bottom line. So that's the equation that we are more familiar with the equation of a circle with a center at HK and a radius of R. So we've got a little bit of work to do. So I'm going to go ahead and take that initial equation, and I'm going to go ahead and group all the x's, group all the y's, and then I'm just going to go ahead and take the constant over there to the other side. So instead of plus 6, I get minus 6. So you want to think for a second, what is it that I am just about to do here? And I think you will see that, well, you can always complete the square. I'm just going to have to do it twice. I'm going to complete the square on x and complete the square on y. So we complete the square by taking the term on the linear, right? The linear coefficient, divide by 2 and square it. Going to do the same thing over here. I'm going to take negative 10, divide by 2, and square it. So I got 2 squared and 5 squared. Often I just leave them in that form on this side. And on the other side, right, if I add 2 squared here, I've got to add 2 squared there. Add 5 squared, I've got to add 5 squared. So all that work, why it was so important, is now we end up with a term over here that we can, right, we've created a perfect square over there. So we've got x plus 2 squared, right? That's what we did right here. We guaranteed that that was going to happen. We've also got y minus 5 squared. Right? That gives us the negative 10y on the inside, and then we've just got to do a little math, giving us 23 over there with the constant term. So there we've got it. We've got a circle. The center is going to be at negative 2, right, where that equals 0, at 5. So negative 2 comma 5 with a radius of, you always want to remember on the other side, this is r squared. So it's a radius of square root 23. Let's go take a look and see what Desmos does for us. So I'll work to go ahead and type this in with you. So x plus 2, then squared, right arrow brings me back down, plus y minus 5 squared. And we saw that when we completed it, we got 23. So there's our circle. All right. Radius of about, right? Square root of 23 is about 5. So just under 5 right there. That looks good. Center is at, right there, negative 2 comma 5. And you might wonder, well, I mean, Desmos is pretty good here. Why don't we just put the original equation in? We had x squared plus y squared plus 4x minus 10y plus 6 equals 0. Oh, we ended up with the exact same plot. So although the technology gave it to us, right, you want to make sure you can be able to do it by hand and get it in standard form, because there's a lot of information in here. The information is in here, but it becomes more graphical. But at least it's nice that we got the same answer. You can kind of see here, instead of, what if we just did that, right? Move the constant to the other side, we get the same answer. Let's try one last one. What if we put the plus 10y over there? That'd be good. So kind of see how this thing all graphs up on Desmos here.